learning goal for today is the student will understand compound probability. Go ahead and take these slides and divide them into two groups. All right, go ahead and tell me, what are some of the different groups that you thought of when you were doing this? Layla.
I put spin red twice, toss heads, then tails, spin red all in one group.
So you put this one, and this one all in one group, and why'd you do that?
I did that because it's telling you to do something, like put it in something like exactly they want you to get that.
That they want you to get that. All right, what are some other choices? Gunnar.
I did spin red twice, pick a number from 10 to 20, and toss heads and tails.
Okay, why'd you choose those together?
Because, I chose those because the other ones are, like, toss heads, and it's like, those ones are more than the other ones.
What do you mean more than?
You spin red twice, and you spin red. You're spinning red.
Oh, because you just
Yeah.
saw the red, but you didn't put those in the same group.
No, because those are all the ones that are bigger than the other ones. Because you spin red twice instead of spinning it once, and you toss heads then tails instead of just heads.
Okay, well, the only one that I question then is why you put this one with it.
Because 10 to 20 is more than 1 through 9.
That's the only one I don't understand. I understand you putting those two, and I understand what you said about those, but then that's where you lost me. So I think he was on the right track with this. What is different about these two that I have starred versus all of the other ones? They do it twice, okay? So these two, if I toss heads and tails, spin red twice, those require two actions. Remember when we talked about actions? Actions are whatever we're doing, okay? If I look at the other ones, all of those other four, that is just one action. So if you look at the next slide, I've actually put that on there for you, okay? This is what's called compound probability. When I spin something twice, when I toss heads and then tails, I did it more than one time. And I can do it multiple times. I can do it 3 times, 4 times, 100 times. That is compound, okay? Simple probability is everything we've done up until this point where I just did something one single time. That's the difference between the two, okay? That is the first big idea that you need to get for today, that you understand the difference between those two, okay? So I put some examples on this slide of some different types of simple probability. So roll 1 dice, spin 1 spinner, flip 1 coin, all simple probability. Compound, maybe I roll a dice and then flip a coin. Okay, or maybe I flip the coin twice. Those are all compound probability. Anytime I combine two things together, that now becomes compound probability. All right, so let's see. Can you tell me how many actions something has? Because in order to decide if something is compound or not, you have to be able to decide how many actions there are. So look at this slide right here, and I want you to put numbers in each of these 3 boxes as to how many actions they have. First one, choose 1 tree and choose 1 fruit. How many actions is that? 2. That is 2 actions. Good. All right, next one. Assign first, second, and third place ribbons. 3 actions. Very good. Choose a 6-character password.
Put 6.
6. And the reason that is because every time I pick one, so the first number I can choose 0 through 9, right? So I go, oh, I want to go with a 3. And then my next one I have to choose 0 through 9. And I say, oh, I want to pick a 2. And then the next, you know what I'm saying? So it's 6 different actions in there. Very good. So all 3 of those would be an example of compound probability. Okay? All right. So the next thing I need to start talking about as we're doing this, and I put this on each slide, and I have a slide with the definitions, is independent actions and dependent actions. Okay? So every time I'm going to bring this up because I think this is the hardest part about today. All right. So I'm still talking about a compound event. Spin the spinner twice. Okay, so I spin it the first time, and what do you think this means right here? What do you think they're trying to show you?
Red and green.
You got red the first time, and you got green the second time. And so they're going to put it in parentheses like that to kind of show you what you're getting when you spin it, okay? So this is an independent action, okay? When I spin it the first time and get a red, then that's great. Then I spin it again, I get a green. The green did not depend on the red I got before it. Does that make sense? So that's why it's independent. as many times as I want, and it doesn't affect. I mean, I get red, then I get green, then I get blue, I get yellow, blah, 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 blah. I can get whatever. They don't affect each other. Okay? So that's called an independent action. Oops. There we go. All right. Here's another compound event. Okay? This compound event, what do you think that BGGB stands for? Yes, okay? So let's say that I choose 4 people from that group, okay? So the first, what am I supposed to pick first? A boy, right? What are my chances of picking that boy right now?
2 out of 4.
Half. 2 out of 20? 1, 2, 3, 4, 5, 6. Right? And there's only this boy and this boy. Agreed? 2 boys? I mean, we're going to say that boys have short hair, girls have long hair. We're gonna for this example. Okay, so my probability right now is picking a boy. So this says I pick a boy. So I can't pick him now. Alright? Now I get a girl. What are my chances of getting a girl?
4 out of 6.
4 out of 6.
4 out of 5. As you go across that.
Okay, he's gone now, right? He's already been picked. He's already on the team. Okay? So now I pick a girl. So 1, 2, 3, 4. 4 out of 5 to get a girl. Okay? So let's say I pick her. Okay? Now, what am I supposed to pick next?
A girl.
Another girl. Okay? What's my probability now?
3 out of 4.
Okay, do you see how the probability is changing? That everything I do is dependent on the one that was picked before? Okay? That is what is called dependent actions. I can't pick that same boy again because he's now out of the group. I have a smaller group to choose from. And then every time, do you see how that's different than the spinner? The spinner I can get red every single time. I can't pick that same boy every time because now he's been picked out of the group. That's a dependent action. Okay. All right. Moving on to this one. Okay. What do you think this means?
2, 6.
Okay, be specific.
The 2 dice.
The blue I got a 2.
The
Red I got a 6. Green I got a 2. So now think about what I just said. Is that independent or dependent?
Independent.
Why is it independent?
Because you don't keep rolling it.
Yeah, because does the red 6, does it depend on me getting the 2 here? No. I roll this, I can get 1 through 6. Then I roll this, and I can get 1 through 6. And then I roll this, and I can get 1 through 6. They're not dependent on the other one. I can roll anything I want. So that is an independent event. Each one is independent by itself. Okay? All right, let's look at this one. So this one says, which choices show a compound event for this action? The action is I'm going to spin the spinner 4 times. Which one of those, if I spin the spinner 4 times? Daniel? Okay, why do you think the third one? So what does that stand for? What do those letters stand for? Okay, so it says spin the spinner 4 times. So I got a red, a blue, a green, and a blue. Can that happen on this one? Yes. Okay, what else? Gunnar.
2.
Why number 2?
Because there's
4 blues.
Yeah.
Could that happen in a game?
Yeah.
It could. Now, that would be experimental probability, right? Because it could happen. What's the theoretical probability of hitting a blue? 1 out of 4 or 25%. Because I really should only hit it 25% of the time. But could I play a game and hit it 4 times? Yeah. Sure I could. That could happen. Okay, why doesn't number 1 work? Very good. It says I spin it 4, that only has 3 choices. So 1 cannot happen because I needed the 4 to happen. Okay, and then this would be independent, right? Because it doesn't matter the roll, the spin before. Every time I spin it, it's independent on itself. Okay? All right, so here is the official slide. just thought if I introduced it as I was doing it, it made a little more sense. Okay, so this one is saying choose one tile and replace it. So this, I think this is kind of like a play on Scrabble. Like you have all your little letters in front of you and you pick a tile out and you put it here. But this is saying, but then you put the tile back. Okay, if I put the tile back, then I have the same chance to get it again. Does that make sense? So I was kind of thinking like a deck of cards. Let's say I have 4 cards, and I say, Emmy, choose one of my 4 cards. Okay, so she picks this one, right? Okay, and then I say, oh, but wait, I'm going to put it back. Choose again. Does she have the same probability? Yes, because it's back in the deck. But just like the kids one, if I say choose a card, and I have 3 left, now I say choose another card. Yeah, you have to be careful. I'm only going to let you do it twice. All right, so then I have these 2 fingers left, right? So do you see how that's independent on the other one? Yeah, I'm smart. I've done this for a while. See how those are independent? Those are dependent because I didn't put the cards back. All right. All right, here's the second slide. Here is the official slide for dependent. Okay, so I already did this with the boys because I thought it made more sense when I did it with the people. But your probability of choosing a B then is 2 out of 11. But if I don't put it back, now it's 2 out of 10 because I just lost one, right? If I took out another one, it would be how much? 2 out of 9. Does that make sense? Because I'm losing them because I'm not putting them back. That's dependent. Okay? All right, so prove to me you understand what I just said and complete slide number 13. All right, so player 1 chooses a game piece and then player 2 chooses a game piece. So compounding that, player 1 chooses red and then another one chooses green. Is that independent or dependent? Kale, why is it dependent?
I know.
Morgan.
Because player 1 chooses red, then red's gone, and so it's green.
Yeah, red's gone, right? If I choose red, if I'm playing Sorry, because that's what this reminded me of. You guys played the game Sorry. If I choose to be red, you can't be red also. You now have to choose something else. So you are dependent on me, whatever I just chose. So that's exactly right. Okay, second one, spin the spinner twice. That would be, you have only one left. Independent, right? Because it doesn't matter which one I get again. It's not dependent on the roll before it. So that is your independent. Very good. All right, I want you to try one more. This is the harder one. Read through this one. See if you understand what this one says. All right, what do you think about this one? Sophie? You think it's C? So independent. Independent means each one can't affect the other one, right? So remember that's if I choose, so I have 3 people from a group, 2 girls and 2 boys. So if I pick a boy first, what happens then? Then he's out of the group, right? Okay, so this one does not work. All right, very good. Okay, what else do you guys think then? Gavin? B. So choosing 3 numbers from 1 to 10. So if I say choose a number, and so you tell me 8, and you tell me 5, did your 5 depend on what she chose? It did?
No.
Yeah, if I just said pick a number, what do you tell me? Tell me a number. 4, pick a number. Okay, pick a number. Weren't those all independent? Like he didn't pick that because she picked this. It's all independent. I just said choose a number, okay? So this one is independent. That's the only one that's independent, okay? Think about, when you're thinking about choosing kids, think about playing like dodgeball and picking dodgeball teams. And Coach Doral says, you're a team captain and you're a team captain. And you start picking kids out. So if you pick a kid, can Nick pick that same kid? No, that kid's off the table. So that's dependent because his pick depends on what she just did. Okay? All right, let's wrap this up so you understand the 2 big things that we learned today. Okay? First big thing we learned today was now we have compound events and simple events, right? Compound is more than one action. So an example of that is flipping a coin and rolling the die. That's compound probability. Okay? Second thing I went over with you guys is independent actions versus dependent actions. So independent are rolling dice, picking a card, replacing it, and then picking again, spinning a spinner twice, picking a number 1 through 10. They don't depend on the other one. They're independent. Okay? And then this one, dependent,